Hello everyone, I am Lucel Marpadapan and today I'm going to discuss about comparison theorem. So the comparison theorem for improper integrals is very similar to the comparison test for convergence that you'll study as part of sequences and series. It allows you to draw a conclusion about the convergence or divergence of an improper integral without actually evaluating the integral itself. So it states if f of x is greater than or equal to g of x is greater than or equal to 0 on a and infinity, then if the integral of infinity and a f of x dx and converges, then so thus integration of infinity to a g of x. The comparison theorem will allow you to draw the first two conclusions but not the others. The reason is that we were assuming f of x is greater than g of x. So thinking about f of x, if f of x is greater than above g of x, then if f of x converges, we know it will force g of x to also converge. But if f of x diverges, then we cannot draw any conclusion about g of x because g of x could diverge or converge below it. So thinking about g of x, so if g of x is less than below f of x, then if g of x diverges, we know it will force f of x to also diverge. But if g of x converges, then we cannot draw any conclusion about f of x because f of x could diverge or converge above it. So comparison theorem, diverge or converge. If we find a comparison function that we always greater than the given function, then the given function will be g of x and the comparison of a function will be f of x. If we find a comparison function that is always less than the given function, then the given function will be f of x and the comparison function will be g of x. So for example, number 1, the integration of infinity to 1. So x minus 1 over x to the fourth plus 2x squared dx. So the solution, since the interval is 1 to infinity, let's plug in the first few values. X is equal to 1, x is equal to 2, x is equal to 3, and etc. So for x is equal to 1, 1 minus 1 over 1 to the fourth plus 2 times 1 square is equal to 0. So for x is equal to 2, 2 minus 1 over 2 raised to 2 to the fourth power plus 2 times 2 to the second power is equal to 1 over 24. So for x is equal to 3, 3 minus 1 over 3 raised to 4 plus 2 times 3 raised to the second power, it is 2 over 99. And for the x is equal to 4, 4 minus 1 over 4 raised to 4 plus 2 times 4 raised to 2 is equal to 1 over 96. So, for the function in the form 1 over x raised to p, if p is greater than 1, p is greater than 1, then the function converges. So, if p is less than 1, p is less than 1, then the function diverges. Therefore, since 3 is greater than 13, greater than 1, we can say that the comparison function converges, which proves that the given function also converges. And that's it. Thank you for listening.